Hello. How are you guys today?
What's up, Pete? I should just click up. Wait. What is it? Here it goes. I'm just trying.
All right. Hello. Sorry for the connection. So this is Team D and M, Module 2, Chapter 2, Sets and Whole Numbers, Number Theory, and Chapter 3, Numerations and Computations. My name is Laquela D. Roberts.
And I'm Miranda Kurtz. And let's get this rolling.
All righty. All right, Miranda. Let U equals A, B, C, D, E, F, G, and H. A equals B, C, D, G, H, and C equals D, G, H. Locate all the elements of U in the Venn diagram. Question 1, A through D.
Okay, let's look at this. Okay. Wait, I'm controlling the screen? Okay, here comes up our help bubble. Well, here comes up our Venn diagram. We got 3 circles. Okay, when it says locate all the elements of U, it's talking about the whole diagram. Everything will be inside U. Okay, so this is A bubble, there's B, and then there's C. Okay, and then out here, you notice in U, there's only A, so little A comes out here. Come on, bubbles. There we go. Okay. And then we look over here at E, and E is only out here. So it's gonna go on the outside, it's not gonna go in our bubbles. Okay, now we're gonna look at right here, A. We got B, C, D, G, and H. So we look at the one below it, and we look at C. It's in C, and it's in A. So it's gonna go over here in its little spot. Then we're going to look at C, and you see D, G, and H. So H is in A and C. So it's going to go over here. B disappeared somewhere. So that's where it goes. Okay, so B only has F. So that means it only has our little F in the squares. It is not an A. It's not over here in C. And then we have, oh, I'm over here now. Hey, what's up? Okay, it says list all the elements in set B, U, and C. Okay, this is a set. This is what they're going to talk to us about, is always about the sets. Okay, we have our little symbols. The little N right here. I can't see my screen. N means it's in both of them. Okay, U, no, N, I'm getting confused. N means it's intersecting, but U means in both means union. So right up here, we have B, U, and C. So what's in B, U, and C? We have D, we have F over here, we have G, and we have H because it's in both. It says list all the sets in A, and then we have our little N here. That means it intersects in B. Okay, if we look up here in A and B, we have D and H right here. It's in that little section. Okay, our next section, we have C. It says list all the elements in B, and then we have our little N there in C. So we look over here, B and C, and again, we only have D and H. It's not talking about A. Okay, then we have D. It says list all the elements in set A and U. And then we look over here. So we look over here and we have, it has everything in it. We have B, C, D, G, and H. Okay. Okay. Donnie, it's your turn. Let's look at this. Oh, I got all these circles up again. Trying to get to the thing. Okay, where's our question? Okay, it's the same question. It says locate all the elements of U in the Venn diagram. This is 1E through G. Give you the clicker. Okay, there you go.
All right. So as you see, E, it says list all the elements in set E. So set E is here. I mean, set A, I'm sorry, it's right here. So as you see, the set will be the small a, the E, and the F. That will be with this set A. List all the elements in set A and C. So of course, our A and C is in our squared. So the sets will be D, G, and F. List all elements in set A with the U symbol, B, and the C. So our sets here will be D and H. All right, Miranda. Venn diagram shown to the right with attributes described by shape, size, and color. Let CH and T denote the sets of circular, hexagonal, and triangular shapes, representing representing respectively. Let's SLR and B denote the sets of small, large, red, and blue shapes, respectively. The set A contains the shapes that are small and not a triangle. So A equals S, the upside down U, like an N, complete parts A through D.
Okay, thank you. Here's our Venn diagram over here. We have hexagons, circles, triangles. Okay, what we're gonna look at is their size, their color, if they intersect, which is our N, and if they're in a union, means all above. When it has this little line over it, it means not in it, or it means not that shape. Okay, so, okay, it says demonstrate which shapes are found in the set L, and then remember our little intersect H. So we're looking for large, and we're looking for hexagons. So that is what that means. Now we're going to look at B. It says demonstrate which shapes are found in the set C union H. So we look over here in our little help bubble, and we have C stands for circle shapes, and then H stands for hexagons. So our answer is going to give us circular shapes or hexagons. Okay, so we're going to go to the next part. Miss Dominique. Okay, it says Venn diagram shown to the right with attributes described by shape, size, or color. Let CHT denote the set of shapes. Let SLRB denote their sizes. The sets all contain the shapes. Okay, now it says complete. Okay, go for it.
All right, so as you can see, C would demonstrate which shapes are found in the set TR. All right, so as you can see down here, the T equals not the shape, it represents or color, and then the upside down is our intersect. So what you get is not triangular that are red. Demonstrate which shapes are found in the set C intersects S, S intersects R. You get circular or small and red. All right, Miranda, show the Indo-Arabic equivalent of each of the following questions, 3A through B.
Okay, so what's going to help us with this is we have to remember that this is just like if we had a number like 1,200. Your 1 would be in our place setting of ones, the 2 would be tens, 0 would be hundreds, and the next 0 would be thousands. So with our patterns, it's going to come the same way. So our little thing up here are symbols, the Egyptian symbols of powers of 10. We look right here at our little arrow pointing that way, and we notice it says 10,000. So we have 1, 2, 3. So it's going to be 30,000. Then we look up here at our little n, and we have 1, 2, 3, 4, 5, which is going to be in our 10 spot. And then we look over here, our little ones look like ones, and we have 1, 2, 3, 4. So that's going to leave us with 30,054. And then our next ones that are coming up, come on, little ones, where are you at? Okay, here's even more fun. We have more charts to look at. So this is going to be the same principle as our spots in our numbers. So our Roman numerals and their modern equations. So we look over here and we have MCM. So we have thousands, then we have hundreds, and then we look over here at X, which we have 3, which is 10. And then we have a V, means it's going to be 5. And then we have 2 of our little ones, and our number is going to be 1,932. So Miss Dominique, here's some equations for you.
All right, I'm ready.
Okay, so here is your Indo-Arabic equations, and here are 2 more for you.
All right, so as we just seen with Miranda's, that it's going to be about the same thing. As you see here, we have our side triangles, as we can look, or they look like little V's, and we have 4 of those. So each of those is 10. So that's 10, 20, 30, 40. All right. Then we have our triangle, which equals to 1. So you add those up and you'll get 41. Our next one, we're going to do the exact same thing. And they all equal, you know, the lines. A straight line equals 5. Line with the dot equals 6. It just goes on and on and on. So if you do that, you get 5 times 18 times 20 squared equals 3,600. 6 times 18 times 20 equals 2,160. 3 times 20 equals 60. 17 times 1 equals 17. So you add all that up and you get 38,237.
Oh, you got that, girl. That was hard.
All righty, Miranda.
Okay,
demonstrate Latisse multiplications. Question 4, A and B.
Okay, let's get this multiplying going by some squares. Our lattice squares are just us taking it out of a line formation and putting it in a box. So we're going to start up here. We're going to multiply 28 by 32. So we're going to put 2 in one spot and 8 in the other. And then we're going to give 3 and 2 its own spot. Now this is how we're going to do our squares. Right here, we're going to go 8 times 3 is 24. Then you're going to go to the next square. And you're going to go 2 times 3 is 6. Make sure when you put your lattice in that you have your zeros up there. They count. They're going to help. Okay. And then we're going to come to the next one. And we're going to go 8 times 2 is 16. Make sure you put your 1 up the top of your square. It really does help. And then 2 times 2 is 4. Again, your 0. So when we come around, we're going to bring down our 6 because we're going to add. We're going to go 4 plus 1 plus 4 is 9. We're going to bring our 9 down at the end of our lattice. And then we're going to go 6 plus 2 is 8. We bring that down. And then you bring down your 0 because there was nothing there to add. And what's really cool is if you go around your square, it's going to give you your number, which is 896. You can also do the short way and just multiply it times itself without doing that, but who wouldn't want to use a lattice square?
Right.
So our problem in our B is multiply 273 by 628. Okay, here again, we have our squares. Okay, so we're going to fill in our places with the 2, the 7, and 3 up top. Make sure they each have their own section. And then we're going to put these on our side, which is our next number, the 6, 2, and the 8. And then we're going to start our multiplying. Okay, so we're going to start from the side to the up. 6 times 3 is 18. Make sure you put your 1 up top in your box. 6 times 7 is 42. Make sure your 4 goes and then your 2. 6 times 2 is 12. Make sure your 1 goes up. It does matter. Okay, you're going to move down to the next one. 2 times 3 is 6. Don't forget your 0. Then you have 2 times 7 is 14. Your 1 needs to come up here so you know where you're going to add at. 2 times 2 is 4. Make sure your 0 is up here again. We're going to move down. 8 times 3 is 24. Make sure 2's up here and your 4 is down there. We're going to the next spot. 8 times 7 is 56. Make sure 5's up here and your 6 is down there. 8 times 2 is 16. Make sure 1 is down here and your 6. Now here we're going to start our adding. We're going to bring our 4 down. Okay, then we're going to our next spot. 6 plus 2 plus 6 is 24. Yes, it is. We put our 2 up here. You need to carry it over. We have a 4 down there. Okay, now we're going to add. No, that's not. That's 14. Yeah, it's 14. I was like, my 200 confused me. It's 14. Put your 1 up here, and 1 plus 8 plus 4 plus 5 plus 6 is 24. There's our 2. Put your 4 down, carry your 2 up top. 2 plus 1 plus 2 plus 1 plus 4 plus 1 and is, of course, 11. Yeah, it's 11. We got our 1 down here, carry your 1. 1 plus 4 plus 2 is 7. You have your 7, and then you bring down your 1. And again, it's going to give you your answer. 171,444. You just go around. Okay, Miss Dominic, it's your turn to demonstrate some lattice multiplication.
All righty. So as you can see from our last thing that Miss Miranda showed us, it's going to be the exact same thing. So as you're going to see, is we're going to put 964 up there, and then 593 on the side. And so what you'll do is the same exact thing. You will multiply 4 times 5 will give you 20. 6 times 5 will give you 30. 9 times 5 will give you 45. Then you'll do 4 times 9, 36. 6 times 9, 54. 9 times 9, 81. And then you go 4 times 3 is 12, as you can see. 6 times 3 is 18, right here. 9 times 3 is 27. So then you go here and you'll calculate, or you bring your 2 down. And then you got 6 plus 1 plus 8 will give you 15. And then you got 1 plus 1 plus 0 plus 3 plus 4 plus 7 to give you 16. And then you have 1 plus 2 plus 0 plus 5 plus 1 plus 2 will give you 11. You're going to carry that. And then 1 plus 3 plus 5 plus 8 will give you 17. And 4 plus 1 will give you 5. So you will multiply, 964 by 593, and you'll get 571,652. Now D, you'll do the same exact thing, and we will do 2 times 2 will give us 4, as you see. 2 times 5 give us 10. 2 times 9 give us 18. 2 times 4 give us 8. 4 times 2 give us 8. 4 times 5, 20. 4 times 9, 36. And 4 times 4 is 16. 3 times 2, 6. 3 times 5, 15. 3 times 9, 27. And 3 times 4, 12. So as you see, we're going to bring some numbers down. We're going to bring that 6 down. And then you're going to add 8 plus 0 and 5. You're going to get 13. You're going to always carry when it's a number, a bigger number that has 2 digits. And then you're going to have 1 plus 4 plus 0 plus 0 plus 1 plus 7 to give you 13 again. And then you're going to get 1 plus 2 plus 6 plus 2 plus 2 equals 13. And then you're going to get 1 plus 1 plus 8 plus 3 plus 6 plus 1 equals 20. And 1 plus 0 equals 1. You multiply all that, 495 times 243, and you're going to get 120,336. All right, Miranda. Demonstrate rounding to the left most digits to estimate the results of each of the following expressions, then make the exact computation.
Okay, so with any problem, especially if we're going to add, we need, or multiply or divide, we need to do the order of operations. Okay, so this is how you say it. My dear Aunt Sally. So you start with multiply, then you go to divide, then you add, and you subtract. So over here we have 883 plus 465 over 134. So what are we going to do? So we're going to multiply, which we don't have to yet. So next one is divide. So we looked at it right there, and we did divide, but we added first. We should always add first. We added, and that gave us 1,343 over 134. And then you divide, so it gave you 10.05. Okay, so in problem 2, we have some multiplying to do. So we have my dear Aunt Sally. So we're going to multiply first. We're going to multiply 5 times 254, which gives us 1,270. Okay, we're going to bring down 523 right here. Then we're going to bring down 35 plus 7 because it's not time yet because we brought it down. Now we're going to add. Okay, 1,270 plus 523 equals 1,793. Don't forget to add the bottom. So 35 plus 7 is 42. And what's left to do is divide. So now we have 42.69. So that brings us to our
That was very, the way you broke it down, it shows, like, to make you understand it a whole lot better.
Yes. Now it's your turn to break it down.
All right. So as we got here, we got 620 times 430 over 293. And just like you said, the order of operation is my dear Aunt Sally. So you're going to multiply the 620 times 430. You're going to get 266600. And then you bring the 293 down. And then you divide that and you get 909.89. All right, Miranda. Computing base 5 and base 6.
Okay. Okay, who's confused about all these dots? I was. Okay, so here, this is going to help you out. What you need to remember is we are not subtracting 1 or adding 1. We're either adding 5 or we're going to subtract that. So over here in our first bubble, well, over here in our equation, it says compute the sum of 4,325 plus 1,335. Okay, so in our squares up here, we're going to do the same like placements like we had in our charts way back a couple of slides ago. So we have 4, 3, 2. So right here in our 25th spots, we're going to put 4 dots. In our next square of 5s, we're going to put 3. And our next square is our 1s. It's going to be 2 dots. And then we're going to bring down 133. Okay, our first spot is going to be 1 dot. Our second spot is going to be 3. And then our next spot is going to be 3. Now, you're going to add and you're going to bring these down. So we know 4 plus 1 is 5. So we have those right here. Then we know 3 and 3 is 6. We brought 6 of them down. We know 2 and 3 is 5. So what our 5 base is when you have 5, you move over a point, which gives you 1. So down here, because there's 5, we moved 1 over, which we still have 1 down here, but this is going to give us 2. And then we had 1 again because this added to 6, so it moved 1 over. So it made 621. So now we're going to do this again. We're going to do it 6s. So now we're going to look for the number 6. So we're going to put right here, we're going to again, this instead of being 25 5s and 1s, we're going to have 36 6s and 1s. I know it's different, but it's fun. Okay, so we're going to do 6 dots right here in the first spot. Our next spot are 6s, so we're going to have 2 dots. Our next spot, we have 8, so that's 8 little dots. Okay, then we're going to do plus our 73. There's nothing in the 36 spot because there's only 2 numbers. Our next spot is the 6s, and we have 7 dots. Our next spot is 3s. Okay, so we brought all those down. We have 8, 9, 10, 11. There's 11 little dots right there. Remember, when you have 6, you circle and you bring a dot down. So we did. And then right here, 7, 8, 9. Oh, look, there's more than 6. We have to circle our 6 and bring our dot down. Okay, and we only had 6 right here, so we brought that down. So what number that gave us is 745. See, each time you bring a dot over, that gives you your number adds up. So that means 745. Okay, Miss Dominique, here's our next question. We're going to compute bases of 5 and 6. Here you go.
So as you can see that you have, we're going to subtract this time, and you have 414 minus 43, okay? So you have 4 in the blue box, 1 in the red box, 4 in the green box, all right? Then you have 43. In the blue box, we have none because, you know, there's nothing to put there. The second box, we have 4. The third box, the green box, we have 3. So when you subtract 414 from 43, you get 321. So here it is. 4 and 3 is 1, and you carry, and you bring this, and you get 2. You subtract, you get 3. Okay, so that's how you got 321. D, we're going to subtract again. 503 minus 24. So you have the blue, you have 5, the red, none, because it's 0, green, 3, and then 24 for the blue box, you have 0, because there's nothing there. Red, you have 2, green, you have 4. So you subtract all of this, and you're going to get 424 from this, because when you bring it down, you subtract what goes in there, okay? All righty. We thank you guys for listening in. Thank you. See you next time.
Next time.